Let f of x be equal to x squared plus 3x. Part A, find the slope of the secant line joining 2, f of 2 and 7, f of 7. Let's start there with part A. We are supposed to figure out the slope of the line passing through these 2 points, right? Now, what is f of 2? F of 2 is what we get when we substitute 2 for x. Remember, x is just a placeholder. Similarly here, if we substitute 7 for x, the output value associated to 7 should be just this, right? Now let's do the math. This is going to be 2 squared 4, 3 times 2, 6. 6 plus 4 is just 10. And 7 squared 49. 3 times 7, 21. 21 plus 49 is just 70, right? Now let's calculate the slope applying this formula. Difference of the output values on the top, difference of the input values on the bottom. X1, Y1, X2, Y2, right? So this is going to be 70 minus 10 over 7 minus 2. 70 minus 10 is 60. 7 minus 2 is 5. 5 into 60 is just 12. And this should be the answer for part A. Let's go ahead now with part B. Part B says, find the slope of the secant line joining these special points. Base point 6, f of 6. The second point is a general point on the neighborhood of our base point, 6 plus h, f of 6 plus h. Okay, so this guy should be, according to our function, 6 squared plus 3 times 6, right? Which is just 6, 6 squared is 36. 36 plus 18, this is just 54. Okay, and this guy, 6 plus h input value, output value 6 plus h squared plus 3 times 6 plus h, right? Okay, let's do the math now for the second point. And we should get this. 6 plus h squared is just 6 plus h times 6 plus h plus 3 times 6, 18. 3 times h, 3h. Great. So now 6, 54 and 6 plus h, let's FOIL this out. 36 here, 6h here, 6h again, h times h squared plus 18 plus 3h. Great. Simplifying, combining like terms, we should get the following. 36 plus 18 is just 54. 6h plus 6h, 12h plus 3h, 15h, right? Plus h squared, that is by itself there. Great, so these are the coordinates of the second point in general, right? Now they want us to compute the slope of the line containing these 2 points. So we're gonna do something similar to what we did in part A. We're going to identify this with x1, this with y1, this guy with x2, this guy with y2. We are going to take the difference between y2, which is this, right? And y1, which is this, minus y1, over x2. x2 is 6 plus h minus 6. Notice that 54 minus 54 is 0. 6 minus 6, 0. So simplifying this, I should get this expression 15h plus h squared over h. Now, dividing h into 15h is just 15 plus h into h squared, just h, right? Just h. So that should be the answer for part B. On part C, they want you to figure out the tangent line at this base point 6 comma f of 6. That point is just 6 comma 56, right? The base point. Now, remember, in order to compute the slope of the tangent line at some base point, you can take the limit as h approaches 0 of the slope of the secant lines on neighborhood points with respect to these base points, right? So we calculated already this slope of the secant line in general before is just 15 plus h, right? Unfortunately, this computation is easy because it takes just a direct evaluation. 15 plus 0 is just 15. So 15 should be the slope of the tangent line at this base point, right? Great. So now part D, the last part, they want you to take the slope that we got before, the slope of your tangent line, together with the base point, which is this guy that we worked out here, and figure out the equation of the tangent line, right? That shouldn't be hard. I'm going to follow this form for the equation of a line. It's called point slope form with x16, y154. So y minus 54 should be equal to 15 times x minus 6. Working this out, y minus 54 equal 15x minus 15 times 6, which is 90, plus 54 plus 54, y equal 15x minus 90 plus 54 is minus 36. That is all. Thank you for watching.